There are two kids fighting over a PlayStation. So here's the PlayStation sitting on the floor. Now, kid 1 is pulling on the PlayStation with a force of P1. Kid 2 is pulling back with a force of P2. PlayStation has a mass of M. So if we're given, and actually let's say there's some friction here too, mu. So if we're given P1, P2, mass, coefficient of friction for static and dynamic, find acceleration of the PlayStation. So step 1 is draw the free body diagram. Well, let's see. We've got two forces on here. We know that the force from the mass points down, so we'll have mg. And we also know that the normal force points up, say that's n. But what direction does the friction force point? Well, that depends on which force is greater, P1 or P2. So let's say, give some values to these. So let's say P2 equals 200 newtons, P1 equals 250 newtons. Mass of the PlayStation maybe is 5 kilograms. Coefficient of static friction we'll say is 0.7. Coefficient of dynamic we'll say is 0.5. Actually, let's make it a little bit lower. Coefficient of dynamic is going to be 0.2. So since P1 is greater than P2, then that means that the block is going to try to move in the direction of P1. So the friction force is going to fight it. So friction force goes to the left. Well, step 2 is assign a coordinate frame. Well, let's say X is in the direction of motion and Y is perpendicular to the surface. Then step 3 is write the equations. So in the Y direction, we'll have sum of the forces in the Y equals mass times acceleration. But in this case, acceleration is 0 in the Y direction because the block is not moving into the floor. So sum of the forces in the Y direction equals 0. And that equals normal force pointing up, mass gravity pointing down. So this gives us N equals mg. And we know that the friction force equals mu times N. So friction force static equals US mg. Friction force kinetic equals UD mg. So we can find both of these. So if the mass is 5 kilograms, gravity is 9.81, we have 5 times 9.81, which is about 50 newtons. And then if we put numbers into here, so to get static friction force, we'll have 0.7 times 50 equals 35 newtons. And then for dynamic, we'll have 0.2 times 50 which equals 10 newtons. So then we write the forces in the x direction. Sum of the forces in the x direction equals mass times acceleration. And that we have P1 pointing to the right. We have P2 pointing to the left. And we also have friction pointing to the left. So here, first we need to see, does the block move? So we'll check static. So if the block does not move, then acceleration would be 0. So we're going to compare 0, compare that to P1 minus P2 minus static friction. So if the forces end up to be greater than 0, then we know that the object moves. If they're less than 0, then we know, oh, it doesn't move. So here on this side we have 0, and on this side we have 250 minus 200 minus 35. So this is 15 newtons. Well, 15 is greater than 0, so block slides. Because the pulling force is great enough to overcome the friction force. So now that we know it slides, we can actually calculate acceleration. So we go back to this equation. We know that MA equals P1 minus P2 minus FK. So then A equals P1 minus P2 minus FK over M. So we put numbers into this. We get 250 minus 200 minus kinetic friction force, which was 10, over 5, which equals 8. So acceleration is 8 meters per second squared. And since this is a vector, we can specify direction. Well, we know it's moving in the positive x. So it's to the right.